Hi students, now we are going to discuss instantaneous velocity. So this is simply v vector, or in some books it is given the symbol v instantaneous. Okay. Now first of all, have you observed the speedometer of a motorbike or a car? It will be in kilometer per hour. So if you travel, sometimes when you notice the speedometer, it will show 40, 45, 50, 60, 70, like that some numbers in kilometer per hour. So that is called as instantaneous speed. So the speed of the vehicle at a particular instant. In a similar way, what is meant by instantaneous velocity we are going to speak now. So how will you define this? First of all, the instantaneous velocity of your body is defined as the velocity of the body at a particular instant of time. Okay, now already we have defined what is average velocity. Let us begin from average velocity. So the average velocity is given by V average is equal to R2 vector minus R1 vector divided by T2 minus T1. So this is equal to delta R divided by delta T. So this is a average velocity. Now if this delta T, if the denominator delta T is very small, between very two close time intervals of time, that means this change in the time interval, okay, this change in the time or time interval approaches to zero, that is if delta T approaches to zero, then this V average, okay, this average velocity can be called as instantaneous velocity. Okay, so this instantaneous velocity is given by V is equal to limit, okay, limit delta T approaches to zero, this delta R by delta T, delta R divided by delta T, and this is shortly represented as dr by dt in vector form, dr by dt. That is the rate of change of the position vector. Okay. Suppose if the position vector is given as r vector is equal to x into I cap plus y into j cap. So this is the position vector in two dimensions. Is it not? So in this case we can find out the instantaneous velocity is equal to d by dt of x I cap plus y j cap. So that this is equal to dx by dt, dx by dt into I cap plus dy by dt into j cap. So this is the instantaneous velocity. Or I can also write the instantaneous velocity V is equal to this dx by dt is the rate of change of the x component of the position vector. Therefore, this can be taken as Vx into I cap plus Vy into j cap. The magnitude of the instantaneous velocity, okay, magnitude of this V instantaneous velocity. So that is a modulus of instantaneous velocity is equal to V is equal to square root of Vx square plus Vy square. Suppose if you draw a graph like this showing the instantaneous velocity, the direction of the instantaneous velocity, okay. So I am going to show this in the xy plane. So this is x and this is y. Suppose you take this is the instantaneous velocity, direction of the instantaneous velocity v. So you can project this on the x-axis and the y-axis like this, so that this from the origin this length is equal to vx and this is equal to vy. Okay, this is equal to vy, and this v makes an angle theta with the x-axis. So here I can take tan theta. Okay, tan theta is equal to this Vy divided by Vx. And this implies theta is equal to tan inverse of Vy divided by Vx. Same like average velocity, what we have studied earlier. Only thing is, if the time interval approaches closer and closer, very closer to zero, then the average velocity itself can be called as the instantaneous velocity, and it is defined as the rate of change of the displacement. Now I am going to explain the same concept with the help of an example numerical problem. Okay, fine. So this is an example to explain instantaneous velocity. Position vector of a particle is given by r vector is equal to 2t into I cap plus 3t square into j cap, where t is in seconds and the coefficients have proper units. Find the instantaneous velocity of the particle if r is expressed in meters. Second, find the magnitude and direction of the instantaneous velocity at an instant t equal to 2 seconds. Now first of all, what is the expression for the position vector? I will rewrite here. So position vector, here r vector is equal to 2t into I cap. So this is 2t into I cap plus 3t square, okay, 3t square into j cap. So the position vector with respect to time is given. We have to find the velocity as a function of time. So this is v. The instantaneous velocity is equal to dr by dt. Okay, dr by dt. So this is differentiation of r. So by dt of 2t into I cap plus 3t square into j cap. So this is now equal to d by dt of 2ti is 2i cap. So this is equal to 2i cap plus d by dt of 3t square is 3 into 2 6, 6t. Okay. So this is 6t into j cap. So this is 6t into j cap. So this is the instantaneous velocity. We have got in the vector form. So the instantaneous velocity v is found to be equal to 2i cap plus 6t into j cap. Okay. So first portion is over. Next one is we have to find the magnitude as well as direction of this velocity when t is equal to 2 seconds. So what is the magnitude? The magnitude of v, that is modulus of v vector, is equal to v. We have to take the modulus of this vector, and this is equal to square root of the component x component of the velocity is 2. So this is 2 square plus 6t the whole square. 6t the whole square is 36t square. So v is now equal to square root of 2 2s are 4 plus 36t square. But we have to find this value at an instant t equal to 2 seconds. So at t is equal to 2 seconds, the value of the magnitude of instantaneous velocity is equal to square root of 4 plus 36 into t square is 2 square. So 2 square is 4. 36 into 4. So we have to find out what is 36 into 4. So this is now equal to, okay, v is now equal to square root of 4 plus 36 into 4. So 36 into 4 is equal to 144. So this is 144. So v is equal to square root of 148. So t is in second, and if r is in meter means then this unit is v equal to square root of 148 meter per second. If you want, you can find out the square root of 148. Otherwise, we can leave it as it is. Okay. So I will try to find out the square root of 148. So 148. So it is coming as 12.16. Okay. So this is equal to 12.16. meter per second. So this is the magnitude of the instantaneous velocity. Then direction we have to find out. So for that the direction is direction of the instantaneous velocity is given by tan theta. So tan theta is equal to the y component of v divided by the x component of v. So that is equal to Vy. So in this Vx is equal to 2 and Vy is equal to 60. So Vy is equal to 60 divided by Vx, that x component of velocity is 2. So 60 by 2, that is equal to 3t. That is equal to 3 into 2, because at a time t equal to 2 seconds we are calculating. Therefore 3 into t is 3 into 2. So this is equal to 6. Therefore theta is equal to tan inverse of 6. So this is the answer for this second part. Direction of this Vt is tan inverse of 6. So if you find in the calculator, tan inverse of 6 will come as 80 plus some value will come. Okay. So once again, what is meant by instantaneous velocity? The velocity of a particle at a particular instant of time. So the average velocity only is now called as instantaneous velocity when delta t tends to 0. I hope you should have understood fine.